Hey students, this video is going to go over a quick recap on mole conversions and dimensional analysis. So first off, just to review the concept of a mole, the mole is measuring the amount of something. It's just like a dozen is telling us there's 12 of something. A mole is telling us that there's a certain amount of some things, but it's 6.02 times 10 to the 23 of those things. And the reason why we have the concept of the mole is because those atoms are just so small to count. And so the mole gives us a bigger quantity of something to work with when we're trying to do our chemical reactions and things. So we're going to be doing our mole conversions using molar mass, using Avogadro's number to convert between those different kinds of units. So with Avogadro's number, which is 6.02 times 10 to the 23, that can be referring to any kind of substance. And we're talking about elements, we're talking about atoms. We could be talking about ions, which have a charge on them, whereas atoms are neutral. If we're talking about ionic compounds, our representative particle would be formula units. So if we have 1 mole of an ionic compound, which is a metal and a non-metal, we would have 6.02 times 10 to the 23 formula units of that ionic compound. If we're talking about a covalent molecule, which is two or more nonmetals bonded together, we would have 6.02 times 10 to the 23 molecules in 1 mole of a covalent molecule. Okay, and then don't forget that 1 mole of a substance is equal to its molar mass, which you can find on the periodic table. So here we have a problem. Cody found a gold nugget that had a mass of 1.250 ounces, asking how many moles this is. So it does give us some conversion factors right here that we can use to solve our problem. So remember, when you're doing any kind of unit conversion, going from one unit to another unit, you always want to start by writing out your given. So we have 1.250 ounces of gold. That's AU. Now, whenever unit you're starting with, that unit is going to go at the bottom of your conversion factor so that you can cancel that out. So 16 ounces of gold is equal to 1 pound of gold up there on the top. We have to get rid of those pounds. We need another conversion factor, putting pounds on the bottom. This time we're going to switch from pounds to grams. So we have 453.59 grams is equal to 1 pound there at the bottom. But we don't want to know how many grams this is. We want to know how many moles this is. So we need one more conversion factor so that we can convert grams to moles. Well, in this case, to convert grams to moles, we're going to use the molar mass of gold from the periodic table, which is 196.97 grams of gold. The molar mass from the periodic table is always equal to 1 mole. Whenever the unit that you want to solve for ends up at the top of your conversion factor, you're done setting up the problem. And remember, you multiply by any number that's on the top of the conversion factor, and you're going to divide by any number that's at the bottom of the conversion factor. When you round to sig figs are always going to be based off of your starting value. So this number is going to have 4 significant figures. So we would take 1.250 divided by 16 because it's in the bottom, times 453.59 because it's in the top, divided by 196.97 because that's in the bottom. And we would record our answer as 0.1799 moles of gold. Trying to find out how many atoms, we can now take those moles and convert moles to atoms. And it would be atoms as our representative particle because gold is an element. So whatever unit you start with, that unit goes at the bottom. So we would have to put that 1 mole on the bottom. Remember, 1 is always going to go with moles until we get to stoichiometry. And 1 mole is equal to 6.02 times 10 to the 23 atoms of gold. Now, even though I've used my rounded answer at the beginning because I don't want to write all of those numbers down on my paper, I'm going to use my unrounded value in my calculator when I do this next step, okay? So I would round my answer again to 4 sig figs for the end, and my answer would be 1.083 times 10 to the 23 atoms of gold. When you're calculating the molar mass of a compound or a molecule, you are going to look up the molar masses of all of the elements in that compound or in that molecule. You're going to multiply the molar masses by any subscripts, and you're going to add those together. So let's say we want to find the molar mass of cisplantin. We would take the mass of 1 platinum. We would take the mass of 2 nitrogens, because this 2 over here behind the parentheses applies to everything within the parentheses. We would take the mass of 6 hydrogens, and then we would take the mass of 2 chlorines, and we would add all of those together. And so our molar mass is going to be 300.06 grams per mole, really is the correct unit for molar mass. So how many grams are in 3.25 moles of cisplantin? You always start, remember when you're doing a conversion, you always start by writing your given first. So we have 3.25 moles of cisplantin. You could write out the whole formula. You could write out the word. Some people on their AP test have abbreviated this in some form or fashion. As long as you have acknowledged it in the problem, you can use however you abbreviate it down here. If you want to put CP and then put CP down here in your work, that's fine as well. So our moles is going to have to go at the bottom. Remember, the number 1 is always going to go with moles. We're looking for grams, so that's where we're going to put our molar mass. So whatever molar mass you just calculated is going to go up there on the top of this conversion factor. We're looking for grams. We have grams on the top, so we can go ahead and stop our setup and just go ahead and solve. So we just multiply. This value here has 3 sig figs, which is why our answer has been rounded to 3 sig figs. So let's go ahead and try some mixed practice here. So we're trying to find the mass of 1 mole of sodium chloride. You do not have to do any kind of conversion or anything. When it says the mass of 1 mole, that is referring to molar mass. So you just have to look up the values of sodium, which is 22.99, and calcium, which is, sorry, not calcium, I was looking at the next problem, chlorine, which is 35.45, and just add those together. The molar mass of sodium chloride is 58.44 grams. How many moles of calcium atoms are there in 140 grams of calcium? So I would start by writing my given here. Now, because I started with grams at the front, I have to put grams of calcium down here. The number that goes with grams is the molar mass from the periodic table. So 40.08. And that's going to be in 1 mole. Are we done setting up our problem? Nope, because we're looking for atoms. And why is it atoms? It's atoms because calcium is an element. So I have to have 6.02, times 10 to the 23 atoms of calcium. Okay, go ahead and make sure you're doing your calculations to make sure you're putting things into the calculator correctly. You want to do the 6.02 second E23. That little trick so you don't make any calculator errors. My answer is 2.10. I rounded it to 3 sig figs. This makes that 0 significant. Don't forget the times 10 to the 24. You will be surprised how many students will forget to put this times 10 to the 24 on their AP test. And that is atoms of calcium. Number 3, we are starting with grams of copper bromide. We're trying to find out atoms of copper bromide. So we start by writing our given 0.522 grams of CuBr2. I have to put the mass of this down here. So 63.55 plus 79.9 times 2, I believe. Hang on, I put 2 times signs in front of a plus sign. Okay. So 223.35. So the molar mass goes down here. Grams of CuBr2. We have 1 mole of CuBr2 up here. We have to keep going though because it's looking for atoms. So I have 1 mole of CuBr2 up here, and I would use Avogadro's number up here. Now this is where things get tricky, students, because this is not 6.02 times 10 to the 23 atoms, because CuBr2 is not an element, it's a compound. So this is formula units of CuBr2, which means we need one more step when I look at one formula unit of CuBr2, sorry, how many atoms are there in one formula unit? There's 3 atoms, 1 copper and 2 bromines. So I stop here, I do my calculation. I'm going to round to 3 sig figs. And my answer would be recorded as 4.22 times 10 to the 21 atoms. In the last problem, how many grams of CO2 molecules are there in 0.523 moles of carbon dioxide? So 0.523 moles of CO2. What am I putting down here at the bottom? 1 mole of CO2. And on the top goes my molar mass, 44.01 grams of CO2. I am not going to use Avogadro's number in this problem because the problem doesn't talk anything about atoms, molecules, formula units, ions, nothing like that. It only talks about moles and grams. So this is just a one-step problem. So I'm going to have 0.523 times 44.01. And I would get with 3 sig figs, 23.0. A little crazy there. Grams of CO2. And that's your recap on mole conversions. If you need any help and need to go over that, just feel free to stop by for tutoring and I can help you out. All right, thanks.